all, I am K. Surya, working as Assistant Professor in the Department of ECE at SNS College of Technology. So we will see a video lecture series for the subject Circuit Analysis and Devices. The first unit is Mesh and Nodal Analysis of Electric Circuits. So in this video lecture series, we will see some basics of electric circuits and mesh and nodal analysis. So the first video today is the basic components of electric circuits. So before going into the basic components, we need to know about what is charge, what is current, what is voltage and what is power. Also we need to know the units of each and every parameter. So charge is one of the most fundamental parameter which is needed in circuit analysis. So there are two types of charges, positive and negative charges. So positive charges corresponds to protons and negative charges corresponds to electrons. There are many devices in which the positive charge is important to understanding the internal operation. But external to the device, we typically concentrate on only the movement of electrons, which is the negative charges. So electrons will be flowing through the connecting wires. So the unit of charge is coulomb. So in other words, we neither create nor destroy electrons or protons when running in electric circuits. So charge is nothing but motion which represents the current. So the movements of charge will give the current. So a quantity of charge that does not change with time is represented by capital Q, and the instantaneous amount of charge is represented by small q of t or simply as small q. So now we will see the definition for current in terms of charge. So current is defined as 1 ampere by counting the total charge that passes through an arbitrary cross section of the wire during an interval of 1 second. We can also tell 1 ampere is the current that is carried because of 1 coulomb of charge, which is measured in each second in a wire. So value for single electron is minus 1.602 into 10 power minus 19 coulombs, and value of a single proton is plus 1.602 into 10 power minus 19 coulombs. So next one is current. Current is nothing but movement of charges. So we can also tell it as a transfer of charge or charge in motion. So current is very important in analysis of electric circuits. So in moving a charge from place to place, we may also transfer energy from one point to another. So this process is the basis of communication systems which like radio, television and telemetry. The current present in a discrete part has both a numerical value and a direction associated with it. It is also the measure of rate at which the charge is moving. So the unit of current is amperes and it is represented by dq by dt. So a contribution to this total charge will be negative if negative charge is moving in the reference direction or if positive charge is moving in the opposite direction. So 1 ampere is equal to 1 coulombs per second. So there are different types of current as shown here. So the figure shown in A represents the direct current, which will be a constant value throughout, and the figure in B shows the sinusoidal current, which is represented as AC. It will be in like a sine wave or a cos wave. The third one is exponential current, which will be decreasing exponentially, and the last one is damped sinusoidal current, where the current value will get reduced as the time expands. So this is a graphical symbol for current. So two methods of representation are there for the exact same current. So here in the figure A and B, it represents the incomplete, improper or incurrent definition of a current. So in the figure A, we represent 3 amps plus 3 amps. in one direction of arrow, and when the direction changes then it will represented as minus 3 amps. Whereas in the circuit given below, I1 of t is given in I1 of t is given, but direction is not mentioned in the first one, represented as A in the bottom. Okay, whereas in the B diagram only direction is given, the parameter is not mentioned. The C represents the current thing. So current should be represented by an arrow mark along with the parameter mentioned on that. Next one is voltage. So voltage across the terminal pair is the measure of the work required to move the charge through the element. So unit of voltage is volt, and we can also say that 1 volt is equal to 1 joules per coulomb. So it is given by capital V or small v. So an voltage can exist between a pair of electrical terminals whether a current is flowing or not. According to the principle of conservation of energy, the energy that is expanded in forcing charge through the element must appear somewhere else. So sense of voltage is indicated by a plus minus pair of algebraic signs. So here are the signs for voltage terminal. So in the figure A and B, the terminal B is 5 volts positive with respect to terminal A. So in the first diagram A, the terminal marked capital A is positive and B is negative, but the voltage value is given as minus 5 volts. So it represents plus 5 volts. Okay, so the next second B diagram, sign is changed. So the terminal marked A is marked as negative and terminal B is marked as positive, and so the voltage is 5 volts. Similarly in C and D, A is positive 5 volts with respect to terminal B. So these are inadequate definitions of a voltage. A and B represents inadequate. In A diagram, the polarity is not mentioned. In the B diagram, value or the parameter is not mentioned. So the C represents the correct representation of a voltage terminal. So both the sign as well as the parameter has to be mentioned here. So next one is the power. So power is 1 joule of energy is expended in transferring 1 coulomb of charge through the device in 1 second. So rate of transfer of energy is 1 watt. So the observed power must be proportional to both the number of coulombs transferred per second and the energy needed to transfer 1 coulomb through the element. So power is equal to V into I. Voltage was defined in terms of energy expenditure, and power is the rate at which the energy is expended. So this is the sign of the power terminal. So power is equal to voltage into current. So both the voltage as well as the current has to be mentioned along with the signs, the direction of current and the parameters mentioned. So if the current arrow is directed into the positive marked terminal of an element, then P is equal to VI. If the current arrow is directed out of the positive terminal of an element, then it represents the supplied power. In the previous case, it represents the absorbed power. So there are different voltage and current sources. So the mathematical model which we will use to analyze the behavior in circuit will be using voltage and current sources. So all the simple circuit elements can be classified according to the relationship of the current through the element to the voltage across the element. The sources are classified into independent and dependent sources. So dependent sources are used as a great deal in electronics to model both DC and AC behavior of transistors, especially in amplifier circuits. The independent voltage source is characterized by a terminal voltage which is completely independent of the current through it. So independent voltage source is an ideal source and it does not represent exactly any real physical device. So these are the symbols of independent voltage sources. Next one is independent current source. So the symbol is represented using a circle along with an arrow mark to mention the direction of current flow. So in the independent current source, the current through the element is completely independent of the voltage across it. Next one is dependent sources. There are 4 different types of dependent sources: current controlled current source, voltage controlled current source, voltage controlled voltage source, and current controlled voltage source. So the symbols for all these 4 are shown here as A, B, C, and D. So dependent on the controlled sources, in which the source quantity is determined by the voltage or current existing at some other location in a system. So it depends on some other voltage or current. So we can distinguish between the dependent and independent sources with the help of the symbol, where for dependent sources you will be using a diamond symbol to represent it, and for dependent sources, independent sources, you will be using a circular symbol. So here K represents a scaling constant, G is a scaling factor, and R is also a scaling factor. So G is A by V and R is V by A. So hope you understood some of the basics needed for electric circuit analysis. So we will take up some assessment questions. So first one is, which of the following is not an expression for power? Yes, you know power is equal to V into I square R and V square by R. So the answer here is P is equal to I by R. Next one is, a 250 volts bulb passes a current of 0.3 amps. So calculate the power in the lamp. So power is equal to V into I. So voltage is 250 volts, current is 0.3 amps. So 250 into 0.3 will give 75 watts. The symbol used for representing the independent sources is, yes, it is circle. For dependent sources, you will be using a diamond symbol. Thank you for watching this video.